We're going to be talking about the Pythagorean Theorem and the converse of the Pythagorean Theorem. So turn to page 541 with me. Page 541. And as you can see here, we have two learning targets. We're going to know and use the Pythagorean Theorem, and we're going to know and use the converse of the Pythagorean Theorem. Both of these things you've done. Okay? All right, the Pythagorean Theorem says perhaps one of the most famous theorems in mathematics. I would say that's probably right. At least everybody knows the word theorem follows the word Pythagorean. All right, and it only works in right triangles. You got to remember what the legs or what the sides of the right triangle are called. The legs are the two sides that connect to form the right angle. The hypotenuse is the side that's opposite the right angle. The hypotenuse is always the longest of the three sides. And the Pythagorean theorem says, and you've all seen a squared plus b squared equals c squared. But what that stands for is in a right triangle, the sum of the squares of the lengths of the legs. Sum means add, and you know what square means. So you take the length of each leg, and you square the length of each leg, then you add those two results together. Is equal to the square of the length of the hypotenuse. So we all write a squared plus b squared equals c squared. I always think of it as one leg squared plus the other leg squared equals the hypotenuse squared. So as long as you know two of the sides, you can solve for the third. It doesn't matter if it's the hypotenuse that you don't know or one of the legs. You always can solve for the third using this theorem. So let's take a look. On page 545 now, let's find that missing leg. So, one leg squared, 5 squared, plus the other leg squared, x squared. Could I have written x squared plus 5 squared instead? And of course, equals the hypotenuse squared. And then you solve it for the unknown. So that's 25 plus x squared equals 169. Then we subtract 25 from both sides. We get x squared equals 144. And now we take the square root of both sides. Now, a lot of the times, we'll have that as our answer. We'll just have the square root of whatever. But whenever your radicand, that's the number underneath the radical sign, is a perfect square, go ahead and simplify that. What is the square root of 144? It's 12. So, if your radicand is a perfect square, I expect you to simplify it. If it's not, don't. Okay? Any questions? Does that work about the way you remember it working? All right, number 2. Go ahead. Did you notice that x was the hypotenuse this time? Okay. Now, it's not wrong if you change that to a decimal. Was it 14 point something? But just leave it like this. Okay? Just leave it as a square root of 208. Any questions? All right, go ahead and do number 3. Everybody get the square root of 240? All right. Now, over the years, mathematicians noticed something. You know, mathematicians are pretty bright people for the most part. They noticed they kept getting the same sets of three numbers for the lengths of sides of a right triangle. All right? Whenever one leg's 3 and another leg's 4, the hypotenuse is always 5. All right? They, you know, like I said, they noticed that. Now, whenever that happens, whenever the length of all three sides are all whole numbers, that's called a Pythagorean triple. So there have to be two conditions met for a set of three numbers to be a Pythagorean triple. First condition is they have to all be whole numbers, and then the second condition is one of them squared plus another one squared equals the third one squared. And since the hypotenuse is always along this side, it's always the shortest one squared plus the next shortest one squared equals the longest one squared. So, if you get that, if the a squared plus b squared really does equal c squared, and a, b, and c are all whole numbers, we call those three numbers a Pythagorean triple. Now, they kind of want you to memorize these, and I don't think that it's really worth memorizing, but it is worth knowing. And some of them you do need to memorize just because they come up so often. All right, we've talked earlier in the year about 3, 4, 5. 6, 8, 10 is actually a multiple of 3, 4, 5. If you take 3, 4, and 5 and multiply them all by 2, you get 6, 8, and 10. That's also a multiple. So any 3, 4, 5 or multiple thereof will give us a Pythagorean triple. Well, 5, 12, 13 is pretty common. The multiples, you know, I really wouldn't remember those. I might try to. I probably won't. And then you run into these others, you know, I don't usually remember them. The ones that you definitely need to know, you need to know 3, 4, 5. You need to know that the multiple of it, the 6, 8, 10. You need to know 5, 12, 13. Other than that, you know, we'll figure them out when we need to use the Pythagorean theorem. Okay? But those you ought to know. So, if the measures of the sides of any right triangle are not whole numbers, then we do not call them a Pythagorean triple. Okay? So if we look back at the ones we just did, those numbers are not a Pythagorean triple because that side's not a whole number. Those three are not a Pythagorean triple because that's not a whole number. Those three, Pythagorean triple because it is a whole number. And so is that one, and so is that one. All right? All right, let's see. Number 4. It says use a Pythagorean triple to find x and then explain your reasoning. Well, my guess is then it's probably a multiple of one of these. So, I don't know, let's just look back at our little chart. Do we see one where the hypotenuse is 35? I don't. What'd you say? It's a 3, 4, 5. It's a multiple of 3, 4, 5. So if the hypotenuse is 35, what are we multiplying by? 7. So here the chart's letting me down a little bit unless I go and look at this, right? So I must be multiplying by 7. I think. Let's see if he's right. So if that's 5 times 7, and then one of these should be 3 times 7, and one should be 4 times 7. Well, that looks like 3 times 7. So this one must be 4 times 7. So what does x equal? 28. Now, could I come up with 28 without trying to find a multiple of one of those Pythagorean triples to use? Yeah. Just do 21 squared plus x squared equals 35 squared. Now, you're probably going to need a calculator for this. And let's see. Let me open up a calculator here. Now, what was it? 21 squared Okay, maybe this isn't going to work after all. There we go. $21 squared is 441 plus x squared equals 35 squared is 1225. Then we subtract 441 from both sides. So x squared equals 784. Now, I'm guessing then, if I've done this right, I'm not actually guessing. The square root of that's supposed to turn out to be 28, isn't it? So square root of 784 and x equals 28. So it required a little work, but we can still figure it out. Now, depending upon what kind of calculator you have, and depending upon how much you trust yourself to type things in correctly on the calculator, I can do this a little quicker. Okay? I don't actually have to figure out what 21 squared and 35 squared equal. I started with this, right? Couldn't I just go ahead and not figure that out and subtract 21 squared from both sides? So on the calculator, and again, see how yours works. On this one, I can do 35 squared minus 21 squared and get that 784 in one step. So then I know x squared equals 784. Then I can take the square root of it. Okay? All right. Number 5 says the main sail of a boat is shown. What is the length in feet of segment LN? All right. Well, they don't mark this as a right angle for us. But that needs to be a right angle, right? If that's the sail on a boat. So we have a right triangle. All right. So one leg squared plus the other leg squared equals the hypotenuse squared. And I'm trying to bring that calculator back. There it is. All right, so look, if I want to, I can do 45 squared plus 60 squared in one step. Now, I look at the answer choices, and I see that they're either whole numbers or decimals. So I'm going to need to go ahead and take the square root of that on my calculator, aren't I? Okay? So I'll take the square root of the last answer and get 75. So the answer is D. All right. Feeling pretty confident with the Pythagorean Theorem? Yeah, you should. All right, now the converse of the Pythagorean Theorem says this. If the sum of the squares of the lengths of the shortest sides of a triangle is equal to the square of the length of the longest side, then the triangle is a right triangle. So in other words, if it works out that one leg squared plus the other leg squared equals the hypotenuse squared, it's got to be a right triangle. Now, it doesn't matter which one you call A, which one you call B. It does matter which one's C, though, doesn't it? C must be the hypotenuse. And you might be thinking, but if you don't know if it's a right triangle yet, you don't know which one's the hypotenuse. Yeah, you do. Because the hypotenuse, if it's a right triangle, isn't the hypotenuse the longest side? It's got to be. So what you're really seeing is if the shortest one squared plus the next shortest one squared equals the longest one squared. And if it does, it's got to be a right triangle. Okay? Now, we can figure out even more from that, though. We can figure out, okay, so if a squared plus b squared does not equal c squared, we know it's not a right triangle. But we can even figure out if it's obtuse or acute. Okay? So first, the converse of the Pythagorean theorem. If a squared plus b squared does equal c squared, it's a right triangle. And then, really, I'm surprised they don't call these corollaries. A couple of corollaries or a couple of theorems that we can get from that are this. We can tell whether or not the triangle, if it's not a right triangle, we can tell if it's acute or obtuse. And here's how. If the square of the length of the longest side of a triangle is less than the sum of the squares of the lengths of the other two sides, in other words, if c squared is less than a squared plus b squared, it's acute. On the other hand, if c squared is greater than a squared plus b squared, it's obtuse. Now, let me try to, I'm not going to do a proof, let me just try to make this make sense to you. In a triangle, the A, the B, and the C aren't random. Okay? If I call that A, that B, and that C. Now that was random, I put them where I wanted to, except for the C. But the side length that we call little a is always opposite angle A. The side length that we call little b is opposite angle B. Get used to that. That's a real common thing. When we get to trigonometry in a few days, it'll be important that you remember that. Okay? So, the side with the length of little c must be opposite angle C. Now, now angle C is either a right angle or it's not. If a squared plus b squared does equal c squared, c is a right angle. Now think of it this way. If the c squared is less than the sum of the other two, then angle C should be smaller than a right angle. Get it? Less than. If a right angle is our standard, what kind of an angle has a measure less than a right angle? An acute angle. So if the c squared part is smaller than what we expected, then angle C is smaller than what we expected, so angle C is an acute angle. On the other hand, if the c squared is greater than a squared plus b squared, then the c is greater than we expected, and angle C is greater than a right angle, so angle C is an obtuse angle. Make sense? All right, let's see if we can apply this. Number 6. Determine whether each set of numbers can be the measures of the sides of a triangle. If so, classify the triangle as acute, obtuse, or right, and justify your answer. Ooh, what's this part of the directions mean? That's right. To make sure it's a triangle, the sum of the two shortest sides has to be greater than the third side. We did those. Remember? Everybody nod their head yes. We did those. Okay? So is 15 plus 36 greater than 39? Yes, so we can make a triangle out of these. Now we need to decide what kind. So here's the way I'm going to set it up. I'm going to put c squared, I'm going to put a squared plus b squared, and I want to put an equal sign between them, but I don't know that they're equal, do I? So I'll just put a question mark. Or better yet, I'll just make a little chart out of it. And let's see if the two sides are equal to each other. Now, which one has to be c? 39. So that's 39 squared. Doesn't matter which one's a, which one's b. So 15 squared plus 36 squared. All right. So let's see here. $39 squared is 1521. And then I can do the others all in one step. 15 squared plus 36 squared is also 1521. So c squared does equal a squared plus b squared. So what kind of a triangle is it? It is a right triangle. Yeah. If you recognize that as Pythagorean triple, you just put right triangle. All right, we good with 6? Number 7. First, can we make a triangle out of these? Yes, 16 plus 18 is greater than 26. So, c squared, a squared plus b squared, and then let's see what happens. Which one has to be the c? So the 26 has to be the c. Now let's see what we get. So 26 squared is 676. 16 squared plus 18 squared is 580. So they're not equal. The 676 is greater than 580. So I know it's not a right triangle. When the c squared is larger, greater than, obtuse. And go ahead and do number 8. Questions? Now let's take a look at number 38. It's a little different. It says find the perimeter and area of each figure. Now this is a little bit unfair of them because we have a perimeter, it's not. If we find that third side, we can get the perimeter. Area. Been a while, hasn't it? This is what I thought was a little unfair. They spring area on us out of the blue. How do you find the area of a triangle? Yeah, area equals 1/2 base times height. Now, in a triangle, well, in any figure, the height has to be perpendicular to the base. The base is always a side of a polygon. The height is the length of an altitude. An altitude goes from a vertex perpendicular to the opposite side. Now, in a right triangle, what that means is one of the legs is the base, the other leg is the height. It doesn't matter which one's which. One leg serves as the base, the other leg serves as the height. So, do we have enough information right now to find the area of this figure? Yeah. So area equals 1/2 times 16 times 12. Or 1/2 times 16 is 8. What's 8 times 12? What is it? Now, that'd be 96. If they gave us units, what would we do with it? Let's say those were centimeters. What would our answer be then? Yeah, centimeters squared or square centimeters, right? But they don't give us that, so that's okay. We won't worry about it. But we do have to find the perimeter. To find the perimeter, we need that third side. To get that third side, we need to use Pythagorean Theorem. Or, oh, that might be a triple, is it? What is it? it's a multiple of 3, 4, 5, isn't it? That one's 3 times 4. That one's 4 times 4. So the third side should be 5 times 4. So the third side is, that makes it look like I'm doing division. 5 times 4, 20. Well, now we're in business. So the perimeter equals 12 plus 16 plus 20. So that's 28 plus 20. We get 48. Now, would we square the units on that as well? No. So let's pretend they gave us centimeters. That one would be centimeters squared. That one would just be centimeters. Now, they didn't, so I guess I'm worrying about something I don't need to, other than units tend to trip students up sometimes. So let's not get tripped up by them when we get to them. All right, so we can do that, can't we? We can do problems like that. Now, on this one, sure seems like we got a lot of variables here. We're supposed to find x. Okay, it's a right triangle. I see the right angle marked. It's a right triangle. So the Pythagorean theorem must be true for this. So, 1 leg squared plus the other leg, x minus 3 squared, equals the hypotenuse, x squared. Now, we get an 81 there. We get an x squared on the other side of the equation. But when you square x minus 3, you do not get x squared minus 9. To square a binomial, have you ever seen this before, this little formula? To square something means to multiply it times itself, right? So if I multiply x minus 3 times x minus 3, use the FOIL method. X times x, x squared, x times negative 3, negative 3x, negative 3 times x, negative 3x, negative 3 times negative 3, positive 9. So I get x squared, then negative 3x and negative 3x is negative 6x plus 9. So just multiply it out, get x squared minus 6x plus 9. Now that you've seen me do that, does that seem familiar? Yes, for some of you, no, for others of you. I don't need it, do I? I can just multiply it out. Okay? So I multiplied that out. All right, well, let's see here. So I've got x squared minus 6x, 81 plus 9 is 90 equals x squared. And I know what you're thinking. You're thinking, oh, that's a quadratic equation because it's got an x squared in it. And gosh, how did they teach us how to do that? And you're not thinking that? You should be thinking that. We got some work to do, don't we? All right? But look what happens if I subtract x squared from both sides. That we can solve. Add 6x to both sides. What's 90 divided by 6? And we found x. All right, I'm just curious. Does this look familiar to anybody? Here's your assignment. On page 545, do 1 through 31 odd, 38 through 40, 43 through 47, 49, 51, 53 through 56. You might run into a couple that challenge your algebra skills. We'll see.